Hi. So I'm Arthur, I'm from York. I feel a little bit of a fraud in this company. I'm not a network engineer, I'm not a router engineer. My background is actually in security and firewalls and writing some code and then moving into more of a sysadmin type role. Currently I run the infrastructure at the University of York. So York is a medium-sized research-intensive university. So roughly 20,000 students, 3,500, 4,000 staff. In networking terms, we are basically a smallish, 3,500 type business with a very large smallish ISP tacked on the side. If you look at our traffic, it's all generated by the students because our halls of residence are on campus. All this nice Ultra HD that people are busy rolling out, that comes our way, and then our firewalls fall over because they can't cope. So it's quite an interesting set of challenges, and it's a fun job. So this is what I want to talk about. It's obviously an oxymoron. It's not the 90s, no shit Sherlock. But IP is the same as it was. IPv6 is pretty old. Yeah? Wi-Fi has been around quite a long time. Even more than that, the way we manage things, the way we manage devices has not changed. In most cases. And that's where I want to talk about how we manage devices rather than maybe what we're doing with them, and what the things that the sysadmin community have learned, and maybe how that relates and whether that's of use to networking. So this is a chart from a guy called Simon Wardley. I don't know if you can actually read the axes along the bottom, but basically the supply goes along the bottom. So your supply is unknown, it's hard to do at the bottom left. It's defined, it's easy to do, it's scalable at the right. And then demand goes up, so you start with novel and you become common. So if you think about computers as a whole, you start off at the bottom left here with things like wire-wrapped memories in the 40s and the 50s. And then you go through mainframes, the microcomputer revolution, the PC revolution, and now up at this top right, the utility bit, the AWSs, the Amazons, and the Google compute engines of this world. And as you move through each of these, there's change in the industry as well. Mainframes gave way to micros. Micros gave way to PCs, and all the companies that were big in the microcomputer world did not make it. Similarly with the whole PC to cloud and mobile transition, Microsoft might make it. They're doing some really interesting things with Azure, but there's a lot of the other companies that are finding this very, very hard. Similarly, on the networking side, you can look at things like Cumulus Linux, some of the white box vendors. They're moving, up the stack. And the other thing about this diagram is that things are rarely replaced by something that's better than them. Okay? Because it's easy to look at a white box router and say, actually, it's not very good. It's not a core router. But that doesn't matter. The things, when microcomputers were replaced by PCs, all the VAX guys laughed at the PCs. They said, oh, they're rubbish. You can't do this, you can't do that, you can't do the other. No, it's true, you couldn't. There was a whole bunch of things you couldn't do. But it didn't matter because they got better much faster. Okay? So keep that graph in mind and then have a look at this one. So how do enterprises adopt IT? And I'm trying hard not to swear too much in this talk, so I'm not going to read it out. But if you look at where we are in terms of the way we manage sort of systems and software development in enterprises, the Googles and the Facebooks of this world are in the sort of the rest of the world. The enterprises are somewhere between the oh no and the far right. We are suddenly going, oh no, we need to do this, better catch up. When it comes to networking, where are we on this graph? So, this is my thesis, basically. Infrastructure practices haven't changed, or they certainly haven't changed enough. So, I'm going to mock the Windows guys, because it's always good. So what we've got on here is, example of a GUI. There's a Windows MMC snap-in and configuring Windows Firewall. The problem with GUIs is that they're basically rubbish, okay? They're great sell. You can sell them to management. You can come to someone like me and say, oh, let's do this because we want to have less skilled staff. And it's, and get monkeys to click the GUIs until you want to do it 3 times, at which point you've got 3 systems in inconsistent states. Until you want to say, what did you change last week? It's like, well, we ticked some boxes. And then you've got to have this whole process that you wrap around it, where you have, your change control and your rituals, and you document what boxes you've ticked, or maybe you don't. And Microsoft have learned this, because they're now trying to run a cloud at scale. So if you look at something like Windows Server, rather than running on a GUI, we now have Windows Server Core and Windows Server Nano, which have no GUI at all. Okay? You run up Windows Server Nano, no GUI, you cannot log in. And it's managed via PowerShell and remoting. Okay. So they've learnt PowerShell is a sort of tool for managing Windows servers. It's explicitly modelled on the old Linux scripting. So the guys that wrote it came from a Linux background. They knew Bash, and they said, how do we make it better? How do we port it to Windows and make it better? So on one end, you've got GUIs, which are a bit rubbish in many ways. But, hey, we're all router guys, so this sort of stuff. Trouble is, this is rubbish as well. It doesn't scale. Basically, if you've got more than a few hundred, a low hundred number of devices to manage, this becomes very difficult because you get all these same problems. How do you know you're doing the same things? How do you avoid fat finger errors when you're typing in? How do you diff your configs? It's, I think, better usually in that you can generally extract a config file from devices like this and have it as a plain text file, and at least you can do some diffs on it. But it's still very problematical. And the analogy of this in the systems world is sort of Linux guys logging into a box via SSH, editing a load of config files and restarting a few daemons. And what we found is that doesn't work. It doesn't work at scale. So, where do we go? So this is a figure from James Hamilton, who was a cloud architect at, I think, AWS. Can't quite remember. So he gave this figure of this was the server to admin ratio for cloud providers. This was a few years ago, 2,500 to 1. And I tell this figure to people, and they all go, oh, that's really unfair. They've got all these servers that are all the same, and mine are all different. It's like, yeah, well, it's unfair, it is. But it's still a very relevant comparison, because that's the people that you're competing against. They've found out a way to make this work. And the other way of looking at it is maybe you get other things from that automation. So the things that enable you to do this, maybe they have other wins as well. So let's step back from infrastructure a while and go and talk about software. Okay? So actual software developers, people writing modern web apps, how do they do it? So I give fair warning that in this section I'm going to talk about sort of different styles of development in a very sort of cartoony way and say, this one looks like this and this one looks like this. Yeah, and it sort of does in reality and it sort of does in reality, but just to make a point. So this is the sort of the caricature of the old school. It was called waterfall development because, as you can see, the water starts at the top and runs down. So you have a massive project, you get a load of people. You start at the top with your requirements, you design it, you implement it, you verify it, and then you put it into production and maintenance. And by the time you've done all that and you put it into production, the requirements have changed and what you've produced is of no use whatsoever. It's a bit of a flaw. And this was known back in the 60s. There's a guy called Fred Brooks wrote a book called The Mythical Man Month in the 1960s, talking about the IBM S360, which was a famously late project to do a new operating system. And they knew all about this stuff. But there's another problem with this, which is that you have your developers, they write all this code, they get down to the bottom, and there's a box here that just says maintenance at the bottom right. Throw it over the wall and we give it to ops. It'll be fine. And again, that doesn't work because, you build something with no concern for how you run it in production, how to make it reliable, how do you test it, how do you monitor it? Well, not my problem. Not my job, mate. So that's what prompted the Agile movement, was they said, okay, this is rubbish. Let's try and do it better. Let's close this loop round and let's do it faster. So rather than designing a big system up front, let's take the smallest bit of it that we can do and deploy that really quickly so that the requirements are not out of date by the time we come to do it. And then let's just repeat and let's get better and keep doing it. And so that's what the Agile guys did. They said, customer value, business value should be generated as soon as possible, and then you just keep going, and that the people that run the systems, or the people that build the systems, should be involved in some of this deployment and running. So out of that came some Agile projects, which I've talked about, And then the other key features of sort of modern software development are revision control. So you put your code into source control. That probably sounds like motherhood and apple pie now, but certainly at York we had pretty much a 2-year project 4 years ago to try and get all our code into source control. It's actually really quite hard in a decent sized enterprise just to find all your code. Oh, it's running on a server over there. Well, where's the original version? Yeah. Joe that left 5 years ago wrote it and it's still running. Where's the source? No idea. Tests, again, all this stuff that's been written, this legacy stuff, will have no tests. So you can start writing new tests at least, and you start making this better bit by bit. And if you've got that second and third thing, you've got revision control and test, then you can do what's called continuous integration. So now I write some code, I make a change, I commit it to source control. From source control, it's automatically pulled into a continuous integration server, which runs my tests for me. And if the test fails, it rejects the commit. So you've got this safety net. And then you can go further and go, if the tests pass, automatically deploy it all the way out to production. Okay? And that's what we're doing at York on some of our better software projects. And as we roll out new ones, we're doing this on nearly all of them now. The interesting thing about this is that you're doing things faster and better and more reliably. It's like this holy grail. I'm going to skip A/B testing. So DevOps. So DevOps as a term is really new. It's possibly, it's now buzzwordy and even Gartner's heard of it, but it's there. So it was founded 2007 by a guy called Patrick Dubois in Belgium, and it's an interesting example of a European-based software movement. Okay. And what was new was not so much what was being done as a way of thinking and almost a branding, if you like, a pulling together of things. So these things about automation and deployment and small cycles, they all existed. And what the DevOps movement says is, actually, that's what the software guys are doing. Let's apply it to infrastructure. And that had been done before. It had been done sort of 93, 94, a site called infrastructures.org, and the University of Edinburgh over the road was writing their own things. But that never grew anywhere. There was these tiny, tiny little pockets of people doing things. So they gave it a name, and they called it something, and it went somewhere. So how do you do all those things with code for infrastructure? Well, you do these things. So start at the top. You want your code to be declarative. So on the software side, on the server side, you want to say, I want a package installed on this router. You don't want to say apt get installed bind. You want to say package bind should be installed. And then whether it's Red Hat or Ubuntu at the back end, that's a detail. Somebody else can deal with that. It should be idempotent. So if I run this thing twice, that shouldn't matter. It should, I can run it as many times as I want and I end up in the same state. Okay. And that's part of the declarative thing, because if I'm declarative, it's a lot easier to make me idempotent. If I'm idempotent, then I can just run it every 30 minutes or every 15 minutes or whatever, and I can get something that's going. It should be testable, for all the reasons we talked about. Code and text-based, again, because I want it in source control. I want my infrastructure now in source control. And it should be open. I do not want to be locked into HP, IMC, or whatever. That's vendor lock-in is always bad. So how do you do it? Highest level infrastructure type sort of block diagram here. Some way you have a master that has your configs and you push out to your clients. Or alternatively, you have a master that has your configs and your clients phone home because they've got an agent and they pull down the config. And there's basically two models. Puppet and Chef basically do pull, Ansible and Salt. Ansible and Salt do push. Push tends to work better in a networking environment where you're not running daemons on the end devices, which is why things like Ansible are winning in the networking space. Probably other reasons, but that's going to be part of it. You can't run a Puppet daemon on a Cisco switch. In terms of what it looks like, this is an Ansible playbook. As you can see, this is actually just running commands. But this is then encapsulated in a library. So you're hiding this config, and you're making it repeatable. And because you've got things like your BGPAS in there now as variables that you're going to pull out, then you can also test it with different ones. And you have scope to abstract and simplify and pull out your commonality. Will be good. So at that point, we're done, aren't we? We say, OK, the networking tools are a bit immature, but we'll just wait for them to do it. We'll code everything, and we'll all have lots of time off. Unfortunately, no. So I'll just talk a little bit about what we've done at York and how it actually works in practice. So there's this basic problem, which is that it turns out that writing code is actually quite hard. So now you've got your original problem domain, you've got your networking or server administration, which is quite hard, and you're going to write some code, which is also quite hard. You just doubled your problems. It's not immediately obvious maybe that this is a win. But it does give you a win, and if you stick at it, you get there. So we've been doing this a long time. We use Puppet on the server side. So we've been doing this since 2008, and we've now got to the point where we have a lot of Puppet code. Nearly all our services now on the Linux side run from Puppet, and we can rebuild them. This system called SITS here is one of these classic, hideously horrible legacy enterprise systems that everybody has, and we all run our systems off. This actually is a student records system, which is obviously quite key to a university. It's lovely. It's lovely. But we've wrapped that up, and we've managed to deliver it with Puppet. And we've got tests, and when this thing's application servers get overloaded, which they do all the time, we can spin some more up. On the Windows side, we can install NSX via PowerShell, so we can have a bare box and bring it up to being an NSX host. And we're looking at Ansible on the networking side. Particularly, we're looking at Ansible as a first go as a way of getting information back. So here's a switch in a data center. Here's a server. It's a VMware server. It's got 93 VLANs going into it. Have I mapped them across correctly to the switch? And then we'll look at things like doing SNMP. I want to change my SNMP v3 config on all N100 of my devices. How big this stuff is an interesting question. So lines of code is a rubbish metric as a metric of productivity. How many lines of code have you written today? Meaningless question. As a measure of complexity, though, it's great. Orders of magnitudes of lines of code is a really good measure. A 100-line script is qualitatively different to a 1,000-line script. It's different to 10,000 lines. BMW's new top-end cars, their adverts say they've got 100 million lines of code in there. Whoa! That's just deeply scary, It's massively complex. But what you get out of here, so the top line here, we've got 75,000 lines of Puppet code. So that doesn't include config files. It doesn't include scripts that are deployed. The next thing is 250,000 lines of those scripts that we deploy with Puppet. Okay? And then all our network config, all our switch configs and router configs are all in source control. And there's a bit over 500,000 of them. The dev guys have roughly 5 million lines of code. But if you add those top three up, you're not far off 1 million. So the orders of magnitude of the complexity of the dev environment and the infrastructure environment are actually pretty similar. And if you say the complexity is similar, then should we not be using the same sort of testing and rigorous methods to try and improve what we're doing? The only problem with having 75,000 lines of Puppet code is that you've got to maintain it. And we've got 6-year-old code now, so we actually have legacy Puppet code that we had to have quite a big project to update from one version to another. So all these problems that developments have suddenly becomes an operations problem. But that's basically a good thing. And it's a good thing because your problems exist. You can't never solve your problems, but you put them at a higher level. You said, let's do them differently. And there are solutions to these problems in the development world. Now, how these are going to apply to networking is an interesting question. So microservices is about how do you split up your domain? How do you make things that are small enough that people can understand them? Two pizza is similar. Don't make your teams too big. Code review your code, tests. Anti-fragility is an interesting model. It's saying rather than let's have the highest uptime possible, let's not do that. Let's have the most resilient system. So rather than trying to keep everything up, let's kill them occasionally and make sure we can work around it. Can you take out a distribution router and just power it off? How long does the network take to reconverge? What happens? Can you make that better? So we did a test at York in Christmas last year. We switched off one of our data centers. We not quite flipped the switch, but we took the power off. We waited for the UPS to die, and then everything died. And we saw what happened. I mean, it was It was quite a stressful month leading up into that, but we learnt an awful lot. It's a very stressful month, actually. But so for the final few slides, before we stop for questions, ITIL, DevOps. One of the things that DevOps was created almost in opposition to was ITIL. Yeah. It's change reviews, you've cabs, so you've got a bunch of people that know nothing whatever about what you're doing, and they're going to tell you whether you can do it or not. Does that add any value whatsoever? Well, maybe sometimes. But DevOps was explicitly saying, actually, maybe we need to think about when that's not appropriate. So DevOps is a cultural thing. We always talk about the tools and what the code looks like and how much code we've got, but really it's a cultural change. It's about how you do things, and it's about how you get buy-in from your senior management to do that. Because if you get it right, this is what you can get, and this is what we're getting on the systems side now, that we can do things faster and better, which is the holy grail. It also gives you the opportunity, of course, to destroy your entire infrastructure in one go with one commit. Swings and roundabouts, But that's why you can't just do this, and it's why you need the testing and why you need everything else. Going back to ITIL for a second, change control is a good thing in some ways. So if you're replacing one of your core routers, then you want some change control and some process around that. Standard changes are one of these things that really annoy me, because there's great potential in most organisations, if your standard changes are like ours, to just break everything with a standard change. But they are great candidates to saying, well, actually, can we get enough testing around them? Can we get enough monitoring around them to say that actually, now it doesn't matter? So we've put a lot of time into monitoring at York. We've got a status board that does live end-to-end testing of all our major systems. So we know really quickly if something breaks. And that is brilliant, especially when you do something like that data center power off, because you've just got a page that you can look at that is updating in real time, and it tells you whether you've managed to get your systems back. And the way we've done that is a public dashboard that it won't tell you that 3 of the 4 servers are down and 5 racks are broken over here. It'll just tell you, can your user log in and get some information out? Because that's all they care about. So if you get enough tests and enough monitoring, then you can change the process. And that's why it becomes a cultural change. So, last 2 slides. What version is your infrastructure? If you roll out software, you know what version it is. We just change infrastructure. What was your infrastructure like a year ago? Can you tell me that? That big long number at the bottom is the SHA hash of the Git repository that our Puppet is on a certain date. It's not a bad approximation to what version is my infrastructure. Not all of my infrastructure, unfortunately, because it doesn't include the network. And that's what we're going to be doing over the next bit. But we're going to start very small, because the networking tools are basically pretty immature at this point compared to the server-side tools. I would not do this in major production. It's something to start looking at, certainly on standard switches. Right, subliminal message. For whatever reason, these seem to be the technologies that are winning in the networking space. If you look at some things like Arista switches, they've got Python embedded. You can extend the CLI via Python, which leads to some interesting ideas. And Ansible. I was talking to somebody earlier who was talking about using Salt, but certainly one of those 2. Those are the correct tools to use, or at least to play with and to try and see what they're like. What you'll find is that the vendor library, so we use HP switches, they've released some Ansible libraries for Conware. They're not really very good, just not. So we're going to have a look at doing those again and maybe working with them to get some better ones. Because, it's all new and it's all immature. But if you look at where the server guys were sort of 3, 4, 5 years ago, I think there's a very clear direction of travel here. And if you look at where the bleeding edge people are compared to where most of us are, again, you can just see that gap. There we go.
Any questions? Also, anyone wants to volunteer to help Tim with the microphone running?
Hi Arthur.
Hi.
Is this working? Yeah. I'm Nick Hart. I'm from Lancaster University. The question that immediately jumped out from that presentation, which I thought was very interesting, and I'll be name-checking you when I make mine in an hour or so's time. You've described an environment in terms of the network equipment and using the CLI to configure it and all the rest of it, and observing that it's a long way behind where servers really are. Certainly that's my perception as well, but I'm just interested to know whether or not, before you started down the road you're moving, whether you actually looked out to see whether there are any commercial offerings that perhaps act as a layer which would make them... Do you get the question?
Yeah, I do. So there are some things. So we use ClearPass, which is quite nice. So we push out edge devices, edge switches. We've got like 40,000 edge ports. So you plug into that, and mostly we build a switch from a template, we take it out, we shove it in a rack somewhere, we flood patch all our edge devices. You plug in, it looks at what MAC address you've got, and hopefully we have a zero config. That all works with ClearPass because it's a one-off config. What doesn't work is that we've got rubbish building management systems and CCTVs, the way you then have to try and lock a port to a VLAN or do some other manual config on that switch. And that's the bit that really we want to try and centralize those differences from the templated build. There are also some nice GUIs. F5 load balancers are really nice. They've got this nice web GUI. But they've also got, if you just SSH into the box, there's a config directory. And if you edit the config files, it's reflected back in the GUI because the config files are the master, but you've also got this nice one. So there are some things that are pretty good out there.
So Brian Nisbet from HCANet. You talk about the kind of the processes and tests being your change advisory board. So that kind of assumes that you have access to and knowledge of most of the systems or all of the systems you're working on. And also, I suppose my question is, have you had an incident where something has broken and someone senior has said, what was the change management here? And they've been happy with the answer, we did a bunch of tests beforehand.
So yes and yes. But we haven't broken anything badly enough to get anybody really senior annoyed. So I'd have to qualify that. Within IT, I count as the senior management, so I can say, yeah, it's fine. But what we're trying to get a culture of is actually not just ticking the boxes. And that works with some people, maybe less so with others. So yeah, there's no right answer at all. We're not in a finished state on that one, I think.
Hi, it's David Gross from Sky. We came a little bit into this same place from the underground. No management support, loved ITIL, loved change control. We had a little bit of a background movement going, exactly the same tools we've used, Python, Ansible, etc. And one of the places, we're having some moderate success, but one of the places we really have trouble is incorporating the software testing philosophy into places where your test resources are highly limited. Like, one of the big advantages you have in a software world is you can spin up a VM or a container or whatever, and it's just the same in production as in stage. Like, we can't really have a pile of Cisco NCS 6000s lying around to test on, right?
Yeah, sure.
And you can only test on a virtualized version for so much, right?
Yeah.
You don't find problems. And so what we're really struggling with that. But one of the ways we're kind of getting around it is to try and have yet another abstraction system that abstracts your access to the testing environment so that the test environment can be rebuilt multiple times to hit multiple people's testing.
That's really nice.
I like this, but it's getting management on side's been hard work.
Yeah, no, I think it will be. So some things that, software developers do A/B testing, which I skipped over. So, you do one thing for this set of users and one thing for this set of users. Yeah, so 50% of my users, your port is down, 50% of my users, your port is up. I think we can see how that's going to go. But when you're automating this stuff and you're abstracting stuff, there's multiple layers of testing. There's testing that the libraries that you use and testing that those work correctly. Clearly, I didn't switch my own phone off. And there's also monitoring as testing. So if your monitoring is good enough, can you get something out of that? Right, sorry about that.
I got a bit of comedy for the audience, which was testing. One of our tests, our old hardware tests, was try turning off both power supplies in the box and making sure it fails. And somebody automated that test and then wondered why the rest of the tests didn't work.
Okay, thank you very much, Arthur.
Cool.